2014, we told us about transcranial ultrasound treatment in Alzheimer's disease ethics FAD mouse model for our last presentation of this session. Take it away, guys.
Thank you.
Good morning, my name is Anvita Reddy.
And my name is William Carroll.
Today we'll be presenting our project investigating the safety and efficacy of transcranial ultrasound in enhancing the brain's clearance of lymphatic clearance of amyloid-beta in an Alzheimer's disease mouse model, in which we found that the repeated application of transcranial ultrasound maintains the spatial and recognition memory in 5x FAD mice by reducing amyloid-beta plaque burden. Alzheimer's disease is a progressive neurodegenerative disorder that is characterized by memory loss, cognitive decline, and the accumulation of amyloid-beta and tau proteins in the brain. That's nearly 7 million in the US alone, and this number is only projected to double by 2060. Although the exact mechanism behind Alzheimer's disease is not entirely clear, the recent success of the pharmacological drug lecanemab, which enhances brain's lymphatic clearance of amyloid-beta, has shown strong support for the amyloid hypothesis. And however, despite due to the side effects associated with lecanemab, there is a strong need to investigate further non-invasive, non-pharmacological alternative treatments. Transcranial ultrasound has shown promise in enhancing the brain's lymphatic clearance of amyloid-beta, and its adjustable focal size and penetration depth make it a versatile and compelling tool for further investigation. So our solution to address this need for a alternative treatment is to investigate this non-invasive transcranial ultrasound technique in reducing amyloid-beta burden in the widely used 5x FAD mouse model of Alzheimer's disease. Low-intensity transcranial ultrasound is known to enhance the cerebrospinal fluid clearance or transport and facilitate interstitial fluid transport in the brain via a process known as convective flow that in the perivascular space of the brain, a phenomenon known as acoustic streaming. So we administered repeated transcranial ultrasound using previously optimized sonication parameters. They were optimized by the lab in vitro in porous media to maximize this acoustic streaming effect. And so this positions the study as the first of its kind in evaluating the safety and efficacy of this non-invasive technique in reducing amyloid-beta burden and delaying the onset of behavioral symptoms. So to this end, our first specific aim was to assess spatial and recognition memory in the mice using two established behavioral tests, the spontaneous alternation test, or SA test, and the novel object recognition test, or the NOR test. Our second specific aim was to analyze the AV accumulation using histological staining using Congo red to quantify the number of amyloid-beta plaques in the brain. And the third specific aim was to evaluate the safety of the treatment through behavioral monitoring and histological analysis, including AF and H&E. So the study used 12 male B6SJL mice, and these mice were divided into two groups, the experimental group TUS positive and the control group TUS negative, with 6 mice in each group. All the mice arrived at 8 weeks of age, and they were acclimated to the facility. Following this brief period, object preference testing was conducted in order to ensure an unbiased selection of objects to be used in the novel object recognition test. And following this, at 10 weeks of age, the baseline behavioral testing was done, SA test for spatial memory and NOR test for recognition memory. And following this, the first round of transcranial ultrasound, weekly transcranial ultrasound, was administered to the TUS positive mice, and the TUS was administered stereotactically to the hippocampal region. A total of 15 sonication sessions were administered from 3 to 6 months of age, and the behavioral tests, both SA and NOR, were repeated monthly throughout the study. And at 6 months of age, all the mice were sacrificed and the brains were harvested for histological analysis.
The optimal sonication parameters used in this study were a frequency of 400 kilohertz, a pulse duration of 75 milliseconds, a pulse repetition frequency of 2 hertz, and a spatial peak pulse average intensity of 20 watts per centimeter squared, which can be seen illustrated by the pulsing scheme above. Yes. Each sonication session lasted 30 minutes. The majority of the mouse brain was targeted, centered around the hippocampal region, which can be shown in the sagittal and coronal acoustic pressure maps above. The setups for the SA and NOR tests can be seen on the right, as well as the 5 objects used for the NOR testing. We see that for the spontaneous alternation test, a Y maze was used. The mouse was allowed to freely explore the maze for 5 minutes while a camera recorded the sequence of entries into each arm. The spontaneous alternation percentage was calculated as the number of non-sequential repeated entries divided by the total number of entries minus 2. Novel object recognition measured recognition memory. It presented the mice with 2 objects, a novel object and a familiar object. The time spent exploring each of these objects was measured in order to measure the recognition memory within the rodents. As said, 5 objects were used in this study, labeled A through E. The objects were all of various colors and shapes in order to be discriminated against between the mice. However, they were all of a similar level of complexity. Spatial memory was measured by the correct spontaneous alternation entry rate. An entry refers to the entry of a mouse into, the entry refers to an entry of a mouse into each of the arms. A non-sequential triad of entries indicates a single counted spontaneous alternation. As you can see, ABC and BCA are counted as successful alternations. However, BAB is not. Here we see 3 successful spontaneous alternations with 7 total entries. A high ratio of spontaneous alternations to number of entries indicates better spatial memory. The SA test results showed that within this study, the control group and the treated group both showed similar spatial memories until 3 months of age, where we see that there is a decline in the spatial memory of the control group, whereas the group that was treated with ultrasound has a maintained spatial memory. It should be noted for these graphs that each of the individual dots represents the scoring of an individual mouse, with the bars representing the averages. The brackets at the top represent where we found statistical significance, as measured by a one-tailed t-test. We also ran a repeated measures ANOVA across time. The results of the spontaneous alternation test showed that the number of entries remained constant throughout the experiment, except at month 4, where there was a p-value of 0.01. Overall, this suggests that the performance of the groups were not linked to their overall activity level within the maze. Novel object recognition testing is used to test the recognition memory. It uses the discrimination index, DI, and the recognition index, D3, both of which take the time spent exploring the novel object as well as the familiar object, and the sum of those two, which is the total exploration time. A higher DI and D3 correlates to more time spent around the novel object, which indicates better recognition memory. NOR test results showed a similar trend for recognition memory as we saw with spatial memory, with the 2 groups not differing in their results until around 4 months of age, in which we see a decline in the recognition memory from the control group. However, The treatment group showed that they would retain their recognition memory throughout the experiment. Histological analysis was also conducted via staining of Congo red, H&E, and VAF. H&E staining showed that there were no signs of structural or vascular abnormalities, as well as no damage to the sonicated brain regions. There were no signs of ischemic injury, as shown through VAF, and Congo red was successful in staining the amyloid-beta plaques, as seen above. The quantification results show that there is a significantly lower number of beta plaques in the treatment group as compared to the control group, specifically in the neocortical and hippocampal regions, as well as overall. We also calculated plaque density, or counts per millimeter squared. Plaque density revealed that there is significantly lower plaque density in all of the groups, between the treatment and control, including in the allocortical region. Overall, this showed a 40% reduction in amyloid beta plaques for the treated group when compared to the mice that were not treated.
So in conclusion, the study showed that repeated transcranial ultrasound in 5x FAD mice significantly maintained spatial and recognition memory and resulted in a 40% reduction in the amyloid beta plaque burden. However, there are several limitations to the study that we must consider. Firstly, only male mice were used despite knowing the sex-dependent effect of Alzheimer's disease. And similarly, only the B6 SJL strain of mice were used, and the results may vary across different genetic backgrounds. Additionally, the tau protein, the tau pathology was not further evaluated because this particular strain does not express tau proteins, and the study was limited till 6 months of age. Additionally, although we did analyze the amyloid beta using Congo red staining successfully, using 511S staining could further enhance the detection and the quantification of amyloid beta. Future studies could incorporate wearable transducers to eliminate the confounding factor of anesthesia, and AQP4 blockers could be used to further elucidate the actual mechanism behind this enhanced lymphatic clearance of amyloid beta.
Thank you. We would like to acknowledge our project advisor, Dr. Sangshik Yu, Brigham and Women's Hospital, as well as our friends and family. Are there any questions?
Great presentation, guys. Can you go back to just any one of your data slides?
Absolutely. Any specific one that you'd like?
For this one, like, how did you calculate your error bars? Just because sometimes I see
Standard error.
Okay. Yeah.
Yes.
Yeah. Just because sometimes I see like there's a bit of a spread, but like the error bars don't see that big, so it's a little confused.
Yes. So specifically, yes, all of these error bars across each of the charts show the standard error. And as I stated on the initial slide, all of the individual dots represent the scoring of a single mouse, all of the bars represent their average scoring, and the brackets are showing where significance was found. That is standard across all of these. And for all of the graphs which are shown in this presentation, the same one-tailed t-test was used, as well as repeated measurement of that. Yes?
Do you think that the holder of the IP will transition this to help humans?
We do, so
I was able to use this as a part of my technology innovation concentration, so I did analyze it from a business perspective.
Yeah.
I think it's kind of like the first movers have an advantage in this field so like I said, the sonication parameters that have been optimized by the lab previously, and so it kind of is if you can get protection rates over those specific parameters, and comparing the kind of profit margin to pharmacological drugs, because this is an alternative to pharmacological drugs,
Right.
it's just much, much cheaper and much more accessible and convenient for everybody.
Thank you.
yes.
Yeah, so I think I missed the premise. Is the premise here that the ultrasound facilitates the clearance of amyloid?
Yes, so what we found was that under the optimal in vitro experiments within this lab from previous studies showed that under these optimal sonication parameters, the acoustic streaming effect, which is an effect where pressure waves are used to induce a convective bulk flow, are able to help increase the clearance of extracellular and interstitial waste within the brain regions. And it is using those principles that the sonication was applied in order to reduce the number of extracellular amyloid-beta plaques within the brain. And overall, this experiment is also attempting to show, and was successful in showing, a link between reducing the amyloid-beta plaque volume in the brain and delaying the onset of symptoms related to Alzheimer's disease, supporting the amyloid hypothesis of Alzheimer's.
Where does the amyloid go? Does it go,
Right.
does it get shaken into the blood and then the blood?
So the thing is that the brain surprisingly doesn't have its own proprietary lymphatic system, which is kind of surprising because it generates the most waste, one of the organs that generates the most waste. So what happens is that we don't actually know the exact mechanism of the clearance, but we know that it occurs because our brain is functioning. So what happens is there's this interplay between the cerebrospinal fluid and the interstitial fluid, and there are various mechanisms. For example, the aquaporin channels also are a form of this kind of clearance. So there's multiple mechanisms, and we don't know the individual contributions of each one, and we just know that this helps with one way, and we don't exactly, we need to further elucidate which mechanism it is helping, but we just know that it does enhance the lymphatic clearance through the existing suggested or proposed set of mechanisms that we know about.
Possibly relevant to that is the fact that it's known that transcranial ultrasound also disrupts the blood-brain barrier.
We had found, so the optimal sonication parameters used in this study were shown to not result in any cavitation or disruptions to the blood-brain barrier, and that was also seen within our histological analysis through the use of H&E as well as VAF to show that there was no signs of damage around the sonicated tissues or any ischemic injuries incurred by the mice as well.
Are levels that are assumed to be non-damaging and yet temporarily disrupt the blood-brain barrier.
Yes.
It's used to get drugs in.
Yes, this lab also has other projects utilizing the same technology for drug delivery.
If a microbubble is used typically with the ultrasound, then the blood-brain barrier is disrupted, but without the microbubble, this does not disrupt the blood-brain barrier at all.
The acoustic physics that are underlying the sonication parameters look at the mechanical index, specifically making sure that the parameters keep that mechanical index under the regulatory level, which is about 1.9.
We have time for one more quick question.
So when you measured these mice, all those metrics, that was just one time point, right, after the treatment?
For the measurements, so we measured the mice at each of these time points. So 10 weeks of age.
That's their age, but for a given age, you only measured one
Yes,
time after.
monthly, one assay test, one NOR test.
And we took measurements from each of those monthly tests. The histological analysis is only taking the count from the brain after
Which is
organ
yeah.
harvest.
Great, let's thank our speakers.